here simulates the battery bank so that we can vary the voltage quickly. Otherwise, it will take a few hours from a real battery to value the voltage. This battery here simulates the fuel cell. The ammeter records the current coming from the fuel cell. This is the microcontroller. And this is the connection to the CAN. And here we have the analog to digital circuit. We have the relay, the MOSFET, and the load side of the circuit is the left side. We have a series wound DC motor connected in parallel to a rheostat to have a 3 amp load current. So let's look at the settings right now. The on-off switch represents the ignition key. So right now, my EV is off. And on the computer here, you can see the display. On top, you have the CAN display on the upper side. And on the bottom part of the screen, you have the terminal display that the driver will see. The CAN display goes to the second group, which is not shown. So at a 12 volt, let's say the battery has 12 volts in it right now, and let me turn on the ignition key. My motor starts turning right now, and as you can see, it draws 3 amps from the battery bank, and it draws no current from the fuel cell. And let's look at my system. I need to connect. Once I connect, every time the microcontroller reads the voltage. So right now the voltage is 11.9. It does that through the A to D converter. And as you can see, the actual voltage is 12 volts. So it's a pretty good reading. Let's now decrease the voltage. When the voltage drops below 7 volts, the relay will then connect the fuel cell and disconnect the battery bank. And the EV will keep running. Let's drop the relay below 7 volts. Let's drop the voltage below 7 volts. Okay, let's see what happens here. The relay, you heard that click? That's the relay. My EV is still running, and look at the current. Now we have 3 amps coming from the fuel cell and 0 amps coming from the battery bank because the voltage is too low. Look at the output at the screen. It has a warning message. Low battery, fuel cell is on, the battery voltage is 6.2 volts. And the CAN is transmitting a message that says FPFC to the second group. We have a working system. Thank you.
And I will do it.